Hello everyone. I would like to talk today about a new feature of 0.9 from MeerKAT, which is called the parametric editing of a shape. Parametric editing is a bit more like the fundamental editing that you have. If you have selected a tool, you can change the width, you can change the height, you can rotate the stuff, but fundamentally the shape is still a rectangle. Fundamentally, the shape is still a circle, an ellipse, whatever it is, whatever led to the creation of the shape. The intrinsic parameters that have led to the creation of the shape can be changed by using this parametric editing of a shape. While for certain things like a simple rectangle over here, let me just quickly start again from scratch. Like for a rectangle, for an ellipse, this is very limited. So for instance, you click over here, you can actually change a point on a circle, and that will change the circle's diameter. You can keep that point on the circle constant, and you just change the center around it. For a ellipse, it's very simple. You can change the big axis over here and so forth, so nothing spectacular. For a rectangle, even if it's rotated like that, you can change a bit of a functional parameters over here. If I have clicked on it, you can see over here that you have a slider but no point. You always had the point that you could change, and the slider is just changing, for instance, the rounded corners of a shape. These are very basic changes that you can apply to a shape, but there are sometimes more spectacular things that can be used which fundamentally change the appearance of the element that you created. And let me give you an example of that. If you click here on the polygon, you may have seen that there are a couple of new things that have been introduced over here. While you still have here the standard thing, you click on every single point and you create a regular polygon. You have as well new features. Let me just delete all that stuff to not distract us too much. For instance, you have a regular polygon. Click on the first thing over here, and you have now created by the first click the center, by the second click you have created the first point of the polygon, and you have, for instance, here a regular triangle. If we change that slider, you will have a regular septangle, a polygon with 9 corners, 10, 11, 12, whatever it is. So you see, you can change really quite a lot of the different things over here. If you're ready, you just click on the right, either on the with the right mouse button on the scene, or you would click over here to change back to the selection. Let's do another example to try to have a star. So for instance, in this case, you have a shape that resembles a star. Once again, you can change the center of it. You see that the other points remain constant. You can change that to change its size, and you have a secondary point over here, which actually is indicating the inner radius. So the distance from the center to those points, you can change that too. You can as well change the amount of corners you would like to have. Some of them make sense, some of them don't, and so on and so forth. Density and alternation is another feature which I will speak about in a second. The density, for instance, is that you can see over here. Let's make an example up. That you are actually skipping certain points. And speaking about that, alternation is the very same thing. Let's play with something which might be a bit simpler to understand. Delete the stuff over here. Add a kind of a pentagram, or what do we call a cross star. Once again, the very same features, just change the origin of the very first point. You have here the center on which you can rotate it around. And you have something over here, which is called the amount of corners. And here is something which is called the density. Oops. which is actually skipping every single other point. So for instance, you're skipping one point, going to another one, skipping this one, skipping that one. With the density, you can play around and change the behavioral aspect of that. That is another example of that. So you really can see with the change of the parametric editing, you're fundamentally changing the appearance of it. Let's speak about these things are actually available and exposed on the GUI, but there are other stuff, for instance, on the arsenal of functions that MeerKAT has. For instance, there is one thing which is called a cycloid. Cycloid is, let me just move that a bit around that we can see that better. There's actually two revolving circles, one circle revolving inside. You have a fixed point on that, and the path that that point is taking is actually creating this nice looking picture. So let's change how that is going out. First of all, you can change the amount of iterations. You can change the inner circle and the outer circle, one circle revolving inside the other one. And that will create, depending on the different features that you're having, very nice looking different things. Another example is something like that. And all of these are a bit of very specific use cases, but actually could be used for decorations of certain things. This is the fractal tree. It's an OI. You can see whenever at the end of the first branch, you're adding another Y, and so on and so forth. And yeah, you can over here, you can change the path length, you can change how many iterations you would like to have. You can change as well the growth, so how much of the previous stem you like to have, and stuff like that. Another one is something like that. It's what we call a growing shape. Let's delete this one, or let's move it to the side that we can actually have a look at it. This make it slightly bigger that you can see better. Actually, this is a regular growing six-sided polygon, which is growing with every single revolution. Every single line is slightly bigger than the first one. It's being rotated slightly, and that gives that nice looking features. So for instance, you have how many iterations in terms of how many times should that revolve until the stuff around the center. You can change about that. You can play around, and you would like to have fundamentally a rectangle that you want to have a regular six-sided, seven-sided, eight-sided, whatever it is, thing. And that is as well providing you with a bit of information. The amount of iterations, we talked about that already. The gap is actually indicating how much that should grow by every single thing. So the difference becomes a bit bigger. The growth ratio, how much should actually every single side become bigger than your previous one, and so on and so forth. And there was another family of parametric functions which actually deserve a video of their own. MeerKAT has built into its belly right now a quite extensive engine to build fractals. But that is a video of its own. So I think it's a nice feature, and let me just show you one very last interesting element over there, I think which still needs a bit of polishing. There is a function which is called pgrid, parametric grid. Let me just open that to say I would like to have a pgrid starting at 10 centimeters x, 10 centimeters y. I would like to have 3 rows, 2 columns, and there you go. Okay, which is very similar to the regular grid command. The difference is, though, that you have now the opportunity to change that even on the fly without recreating it. Okay, so for instance, you can change the gap between the columns, you can change the gap between the rows, you can change the amount of rows you would like to have. Okay, 3 rows, but then only 2 columns, whatever it is, and so on and so forth. So let's make 3 rows, 3 columns. Yeah, or let's say Yeah, free. Move it to one side over here. Click on the right click on screen. Okay. And now let me change this one. Okay. Instead of having an 80% branch length, I would like to have it slightly bigger. And have a look. Parametric grid is actually taking the initial node from which it was created and is aware of updates that have been made to that shape and will allow you to mirror that in your picture. Okay, so much from parametric editing. Thank you for watching.